Our learning target for this video is I can explain the gas, liquid, and solid states of matter in terms of particles. So we're going to describe the structure of each state, and we're going to describe the phase changes between each state. So the states of matter that we're going to study are solid, liquid, and gas. So you can see in this picture of a solid here that the particles are very close together, very dense. They have a definite shape, a definite volume, and you really can't compress them or squeeze them into a smaller area very well. We move over to the liquid state, and we see that the particles are still fairly close together, but there's more disorder. See, there's not this nice, pretty structure we have in the solid over here in the liquid. It does have a definite volume, but it's going to take the shape of the container. So just think about if you pour, a little bit of water into a cup, you can pour that into a different cup. You still have the same amount of water, but it has a different shape. And you can compress liquids slightly. Okay, and liquids are often used in hydraulics because of that property. Now if you look over here at gases, these particles are very much spread out. They're very disordered, much lower density. They don't have a definite volume or shape. They take the volume and the shape of the container that they're in. They're highly compressible, so we could squeeze this into a much smaller area, and all the gas would fit because those particles are spread out so much. So let's look at what happens when we heat, because when we go from solid to liquid to gas and we heat them up, we're adding energy, which is what creates this disorder and separation. So the phase changes, if we go from water to steam, are boiling. If we go from steam back to water, that's called condensing. Freezing and melting are probably the two you're the most familiar with. To go from ice to water is melting. To go from water to ice is freezing. Now sublimation and deposition are the least common. Sublimation is like dry ice when you're going from a solid to a liquid, and that's what happens when you have dry ice and it looks like fog. That's the carbon dioxide going from solid straight to gas. Deposition or deposing is when you go straight from a gas to a solid, and this is what happens when frost forms in the wintertime. The water vapor in the air hits the cold ground and immediately freezes into ice, and it totally skips that liquid state. When we graph these changes, we get a phase change graph that looks like this. Down here at A is when we would have a solid, so small temperatures down here. And we're heating that up. That energy going into the system is going to raise the temperature. Now when we get to B here, notice that the temperature is not changing. And we know that at 0 degrees Celsius, that's where melting occurs. So we're still putting energy in, so we're still adding heat, but all of that energy is going into breaking the bonds and causing it to change from solid to liquid. Then once it's all in a liquid state, we're still adding heat energy, so it's causing the temperature to rise. And when we get up here to 100 degrees Celsius, that's where water boils. Notice again that there is no change in temperature, so what's happening here at D is that we're changing from liquid to gas. And notice that it takes a lot more energy to go from liquid to gas. Now we could have a cooling curve, which would basically be just this graph flipped. We can also talk about these phase changes in terms of endothermic and exothermic. Endothermic means that we are adding heat in. Okay, so pardon my handwriting there. We're adding heat, adding energy in. So the phase changes that are endothermic are melting and evaporation because we're adding that energy in. Exothermic is where we are releasing or removing heat, okay, or energy. So these phase changes down here, condensation and freezing, would be our exothermic reaction. Now if we look at that change between gas and solid, so if we're going from solid to gas, this is sublimation. So that would also be endothermic. If we were going from gas to solid deposition, that would be exothermic because we are losing energy. We're releasing energy into the system. So you have to be very careful with these because we tend to think of endothermic reactions, tend to think of endothermic reactions as feeling cold, but it's actually in terms of that adding energy, okay, for the phase changes. And exothermic we tend to think of as hot reactions. In terms of phase changes, we're releasing energy, so we're causing those particles to slow down. So be very careful when you're identifying them as endothermic and exothermic.